We are working still on predicting pH of solutions. If we go back in time, Danny, we had let's see, to get pH, pH is a negative log of the hydrogen ion concentration. So, Danny, how did we get that hydrogen ion concentration if we had a strong acid? Exactly, right? Because it's a strong acid. So if you have 0.2 molar, I don't know, 0.28 molar HCl, well, heck, you know what the concentration of H is, because this is a strong acid. Exactly. And then we moved on to weak acids, Erica. How did we get the pH of weak acid solutions? How do we do that? We use the Ka. Yeah. Had to write a Ka reaction, right? HA goes to H plus A minus. Then everybody made a what table? An ice table, right? Okay. And then we moved on to weak bases. How did we get the pH of a weak base, Danielle? Oh, we have a weak base, though. We didn't write a Ka reaction. We wrote a K. Yeah, do you remember how that went? You take like the conjugate base plus water, you get the conjugate acid and OH. Then we made a what table, everybody? Ice. Okay, so and then you're right. We had to get the hydroxide, but that's right. You could take the negative log of it, get POH, subtract 14, get pH. Okay. So looks like today we're doing the exact same thing over again. Weak bases again. So it should be this. Something's got to be kind of complicated here. Up to now, what's that? Up to now, Daisy, how did we recognize that a solution was a weak base? How do we know that?
When you look at the exponent thing on the
Well,
TV.
Well, it's in the table, right? If up to now we knew it was a weak base because it was in the table. That's what I mean, right? We know that it was going to be a weak base because it's in the table. But now what they're trying to say is there's a second source. Like you can call this the first source. There's a second source of these weak bases. The table of weak acids. Jasmine, do you see any weak bases in that table? What the heck? What are they saying? How can we get bases out of this? Take the H away. Then you have the conjugate base. Yeah, because here's all the conjugate acids. And they're not going to do this. Whoop. They're not going to do this. They should. It'd be nice if they did. Make a whole another column of all the conjugate bases. And just what Jasmine said. Take away an H plus. Right? Take away an H plus. So what are some of those bases? Can you give me the chemical formula of a Sabina? Can you give me a chemical formula of a conjugate base from this table? She says F minus. Right? What did she do? She looked at this guy, and she just took off an H plus. How about another one? Monica. What would be another conjugate base? Okay. Well, you're looking HS minus. You're talking about probably this one, right? And then take off an H plus. That would be HS minus. How about another one? I don't know if you guys are comfortable with this yet. Jarixa. Give me a conjugate base using this table.
HSO4 or SO?
Which one are you looking at?
The hydrogen sulfide. I mean,
So she's looking at the sulfurous acid stuff. Okay. So it'd be HSO3 with a minus. Right? So you take anything in there and just take away an H plus, and you'd have a conjugate base. Okay. So if we are going to do this and get pH of these solutions, we need a Kb for them. Like I see all these nice little Kas. How do you get the Kbs, Vivian? The book gave us a hint. How do you get the Kbs? You can't look them up. You gotta what? Anybody know? You gotta calculate them. Because Kw is what times what? Ka times Kb. Right. So if you want to, I don't know, let's say this is in, right, we're going to have a base, and, well, you have to look up its Kb number. You have to calculate it, right? We'll plug in the Ka for H2S. There it is. Plug in the Ka, plug that number in, and solve for Kb. What's Kw, by the way? Remember what it was? 1.0 times 10 to the 4. Yeah, so we can calculate all this stuff. They expect you to calculate it. They're not going to give them to you. Okay, so we mentioned some bases here. We mentioned that we've got some bases. They all have these negative charges on them. Alyssa, how do you get those into solution? Right? I mean, F minus. How would you get it in solution? Can we just go to the chemical storage area over there and see a shelf that says F minus on it and just take it off? There's something wrong with that. What's wrong with that? That's like going to, in my mind, going across the street to AutoZone and saying, okay, Gabby, go get me the negative terminal of a battery. Well, she goes over there, grabs the negative terminal, well, what's going to pull with it? The positive terminal. You can't separate the two. So we need something positive to go with it. Moreover, we need something positive that it'll make it a neutral compound, but it has to do what in water? 100%. Dissociate, dissolve, whatever word you want to use. You don't want it to be a precipitate laying there on the bottom. Now, when we had General Chemistry 1, there was one group of elements. You put these cations with anything, and they dissolved 100%. It was the first group. So you're going to see this all the time. Pick one. I don't know. Potassium. Kf. That's how you're going to get it in solution. LiHSO3. That's how you're going to get these in solution. You're going to be putting it with a cation, an alkaline earth metal. Okay? And to this day, these alkaline earth metals, they never do anything. So when I see these compounds, I don't see the alkaline earth metal. And that really helps my brain look at this stuff. All I see are those conjugate bases. Don't look at those alkaline earth metals. They don't do anything. Just kind of block them out. Okay, so before we go to the boards, let's work one of these out together. So we're going to work out this first one together. And what you got to do is feel free to use those two tables, 16.1 and 16.2, right? Here's table 16.1 and table 16.2. And what we need to do is determine whether each solution will be acidic, basic, or neutral. And then write the reaction that controls the pH. So in this A, we're putting sodium cyanide in solution. Tegan, would that be an acidic, basic, or neutral solution? It's basic. Now, when you're looking at, she's right, when you're looking at sodium cyanide, don't look at what element. So you totally block it out. Okay? And then, okay, now where is this cyanide thing? Well, yeah, it's actually a negative, but it's the conjugate base of this guy, right? So a couple hints. One is you can find them in the table. The other one is well, heck, it has to be a conjugate base, right? Cyanide, it has to be a conjugate base. It has to be basic. Okay, so you'd write basic. The other part of the question is write the reaction that controls the pH. So it's going to be a basic solution. So Allison, we should write a Ka or a Kb reaction. Kb. And Crystal Munoz, what will that Kb reaction be? Well, leave the, no, Kb reaction. And leave the spectator ions out. Just leave the sodium out. How do you write a Kb reaction? The conjugate base plus H2O gives hydroxide and the conjugate acid. So one more time, Crystal. So, which is Cn minus, okay, plus H2O, good, gives yeah, leave the spectator ion out. It always produces what and what? Hydroxide and the conjugate acid. So here's my hydroxide. What's the conjugate acid have to be? HCN. All right? And you can always write the pluses and the minuses, but no one ever does, right? That's just going to end up being neutral. Okay? Let's do one more since you didn't sound so confident. Gabby. B. Acidic, basic, or neutral? Acidic. Everybody agree?
Which one?
B. How do you know? Tell her, Tegan. How do you know? Cross out the Li. So what has to be left? This has to be what? Either an acid or a base. So what is this? This is a conjugate base. Of which acid? HOCl, right? So this must be acidic, basic, or neutral, this solution. Has to be basic, because we don't have HOCl. We have OCl, it's conjugate base. Okay, so we've got basic.
And then you write that.
Okay, so then, Erica, what, Ka or Kb reaction then? Kb reaction. So that's, to me, that's the logic of it. Figure out whether it's acidic, basic, or neutral. All that matters is what you got. Well, I just have the conjugate base.
And NO3 nitrate is basic, right?
All right, let's just finish this. So OCl. So how do you write that? Danielle, how do you write this Kb reaction? How do we do it? OCl, the conjugate base, plus H2O gives OH minus and perfect, right? Okay. So let's go to the boards. And so what we're doing is we're just prepping for the ice table, right? We're just starting to prep stuff. So we're not going all the way. So let's just go ahead and go to the boards and write down, first figure out acidic, basic, or neutral, right? And then once you make that determination, if you say acidic, you have to write a Ka reaction. If you say basic, you have to write a Kb reaction. And remember, you've got the two sources to take a look at when you're figuring these out. You've got this table of weak acids. So what could be given is verbatim one of these, or it could be one of its conjugate bases, or you could be given one of these compounds. All right? Let's try it and see if we can figure this out. So go to the boards and start with C. And write down acidic, basic, or neutral. And then write the corresponding Ka or Kb reaction. This week is lab 28, by the way. So we have C5H5N. C5H5N.
Well, I also got the C.
So I would have those tables unless you have those things memorized. Because where does this guy show up? Which table? The table of the bases. Right. All right. Do you find it? So he's got to be acidic, basic, or neutral. You just found him in the base table.
Oh, yeah, that's true.
Right? So did you find that compound? Hopefully you found him in the base table, right? C5H5N, did you find him? He's right here.
Yeah, I already found him.
So acidic, basic, or neutral?
Basic.
Basic, because he's in the base table.
Got it.
Okay, so basic, and then go ahead and write the reaction form that controls the pH. Do that for D, E, and F. Acidic, you have to be starting out with an acid. So we don't have all these memorized, right, Daisy? So I would have that table out there in front of you, and you look for that compound, and you're going to find it. Every single time you're going to. These aren't, this is the base table, the acid table. So if it's in here, definitely it's a base. If it's listed as exactly one of these, it's an acid. But if it's listed as one of these conjugates, it'll be a base.
Okay. So if it's like, say it's like a
Like C2H3O2, that would be basic.
What if it's not on the chart?
They all got to be in the chart
neutral.
somewhere.
Neutral. The
Ooh.
Neutral.
E and F. When you get as far as E and F are trick questions.
I think it's neutral.
E and F are trick questions. I call them trick questions. They really aren't, but they are kind of trick questions. Okay.
It's in my brain. Oh wait, isn't it? But without. Group, isn't it like a strong base?
Okay, I think everyone agrees with C. They said basic.
I see what you're saying.
With D, everybody wrote, can't read back there. You guys don't have it yet. D. Now, did you find D? D is HF. What is HF a conjugate acid or a conjugate base? It's a conjugate acid. In fact, it's even in that table of weak acids. So you have to write a Ka reaction. It's going to be acidic. Well, you don't need that group because it's HF. It's already neutral. So you don't need the sodium. So you just HF. So it'd have to be the Ka reaction for HF. Okay. Acidic. HF goes to H plus F minus. Okay, how about E? For a Ka reaction, it's always the conjugate acid goes to H plus F minus. Now, you can't make up your own reaction. No. Remember the Ka reaction? It always looks like HA going to H plus A minus.
So it would just be
HF going to H plus F minus. All right? So do you agree with, let's make sure everyone agrees first. Everybody agrees with D?
Yeah.
This is the Ka reaction. And it has to be acidic. Now E. If I was going to guess E, I would guess what? Basic, right? Because you have this Cl minus. It's a conjugate base. But it's a conjugate base of what acid? A strong acid. So that makes this a very special base. He doesn't do jack. Right? He's too weak. Because if he had some strength, he would weaken the acid, but you can't. So these conjugates, there's 6 of them. right? There's 6 conjugates, 6 conjugate bases that aren't going to do anything and make it a what solution? Neutral. Right? How about F? How about F? Yeah, do you remember this? What was this acid called? HClO4. Perchloric, another strong acid. So F will be acidic, basic, or neutral. It has to be neutral, right? Because you really should write a Kb reaction if you're going to do anything. But remember, the bases, the conjugate bases of strong acids are so weak they can't do anything. So there's 2 reasons to know those. There's 2 reasons to know those strong acids. One is, it's easy to calculate pH. The other one is to cover these trick questions for this part. Now stay where you're at. We're not going back yet. Okay. So now we're here. Let's write the hydrolysis reaction and get a number for its equilibrium constant. Okay? Yeah, there's no equilibrium constant to write. So we're not doing ice yet. We're still paving our way. So write the hydrolysis reaction, if any, and then also determine a value for the equilibrium constant. So that means find out a number for Ka or Kb. It's the same process. Look at it and see whether it's acidic, basic, or neutral. And that tells you what type of reaction to write. If you say acidic, you got to write a Ka reaction. If you say basic, you have to write a Kb reaction. Mm-hmm. Now you have to get a number for it.
I have to write H2O.
Yep. Now how do you write those? How do you calculate those Kb's? We told you.
And then HF, right? HF, no?
Good, very good. Everyone's agreeing that this A is going to be a basic solution. So you're writing a Kb reaction. Very good. So write the Kb reaction and give me a number for the Kb.
Math calculator.
Remember how to get Kb? Kb is Kw divided by Ka, right? Because Kw is Ka times Kb. So Kb would be Kw over Ka.
Is that right?
I don't know. That's what it looks like.
What'd you get?
Okay.
Well, I'm always right. So. Real straight. Be confident in yourself. Where are you from?
Like 1.47 times 10 to the negative 11, about, huh? So for A, make sure you can get about 1.47 times 10 to the negative 11 for your Kb. If you got it, go on to B. Try B. Try B. Yeah, make sure you can get that number. I want to make sure you can do it in the calculator. Yeah, good. Now you have 0.05 molar potassium nitrite. Acidic, basic, or neutral? Acidic, basic, or neutral? Now, if you're not sure, right? If you're not like HNO2, is that a strong acid or not? Just look in the table, because it doesn't. The table doesn't only lists weak acids. So if you see HNO2 in there,
Yes.
you do. So that means KNO2. This solution must be acidic, basic, or neutral. Has to be basic. So that means you have to write a what reaction? A KB reaction. Good. And leave the K out, Vivian. Leave it out. Don't write the K. But you'll have a minus though on the nitrite. It'll be NO2 minus, right? So this will be a minus though. And you add H plus, we'll just goes to neutral.
So we put the plus on.
Yeah, you can put a plus there and a minus there. And you have a minus on your nitrate.
Oh, you want 32?
You have to.
Are we done?
Keep going.
Yeah, we got a page. Plus another problem on this page.
So we're not going to do EX3. We're going to skip that one.
Oh, yay. We still have another page.
So did you get an answer for 2.2 times 10 negative 11? Okay. So make sure you get 2.2 times 10 negative 11 for your KB. Good. You got it? Let's go on to EX4. We have two problems. And we're done with these two problems. I'll give you the joy of handing you back your last exam.
Oh, goodness.
And a grade sheet.
Oh, gosh. Find the hydroxide ion reduction.
So now we're given 0.58 molar sodium fluoride. We want to know what the hydroxide concentration is and the pH of this solution. Good. This is going to be an ice problem. But figure out whether it's going to be acidic, basic, or neutral first, so then you know whether to write a Ka or a Kb reaction. Basic. Good. Vivian, now we have to do an ice table and put in the initial, the change, and the equilibrium row.
You want to solve for KB, right?
Yeah, you need the Kb.
Wait, so
You're going to need that number. You're going to have to calculate that Kb.
that number goes in the X?
Well, no, you want KB, that's the column. Oh, no, that goes in. Yeah. The right?
Kb is products over reactants. So solve for your Kb and get its number. Then it's just products over reactants.
Oh, okay. So,
What was that?
oh, nothing to add.
Vivian, I think maybe we made a mistake. This all looks good, except for right there. This has to be KB. I think you plugged in KA, didn't you? Yeah, so just change that 6.8 times 10 negative 4. You have to calculate that KB, right? Because KB is KW divided by KA. Yeah, because you wrote this isn't the KA reaction. You wrote the KB reaction. So you remember KW is KA times KB. So you have to calculate KB. Right? This equilibrium constant, you have to calculate it.
So I do 6.8,
1 times 10 negative 14 divided by KA.
pH of 12.3. What'd you get? Wait, so
What did you get for your KB?
I got 12.3.
oh, 14.
What I do?
You did 14 minus 3. Yep.
So 2.9 times 10 to the negative 6. 2.9. Okay, a lot of people are getting x to be 2.9 times 10 to the negative 6. So that means the hydroxide concentration is 2.9 times 10 to the negative 6. Because if you're not sure, just go back to that ice table, right? The ice table says that hydroxide is X. So that part's done. And then what I think is easiest is just find POH. Because this is already in your calculator. Just find POH and subtract from 14. And what answer do you get in the end here? I see a lot of 8.5s about.
Yeah.
Vivian, did you get 8.5? Erica? What do you guys get in the back? This is your hydroxide concentration, right? So find the POH. POH is negative log of OH. So 2.9 times 10 negative 6. Take the log of it. Around 5.54 or so. So then my pH, 14 minus that, around 8.5. And before you go on to do EX5, does the pH of 8.5 make sense? Why? You're right, it should. Why? Because it's a basic solution, so you have to get an answer bigger than 7. Good. Try to get EX5, and then we'll call it a day. Okay. It looks okay. I don't know. You have to see what everyone else gets. I don't have the solutions. Oh, careful though, it's OCN. It's not CN, it's OCN. Whoops, that'll.
And is that on the chart? Or is
Yeah, HO, because then you need to find the Ka of HOCN.
Oh, it's right. I told you. I
put O's in there. So Danielle, you see what's going on here? Okay, but now you need to write something here. It has to be a K what? It has to be a K KB. So you have to calculate it because KB is always KW over KA. So you have to look up the KA for this acid. Good. Got it?
Yeah.
Good. Excellent. Yep. Good. Muy bueno. Sabina got about 2.8 times 10 negative 11 for it. Yeah, that's your on your KB, somewhere around there. Yeah, good. So that goes right there. So now you have to look up the KB, right?
Yes.
There'll be X products over reactants, but it has to equal KB. So you have to calculate your KB. KB is KW divided by KA, and you'll get it. So 8.7 makes sense? It should be acidic, basic, or neutral. Basic, yep. Yeah, we'll get our stuff. I'm just making sure everyone gets this figured out first. I don't want to rush them. We have a few more minutes. Yeah, 2.9 times 10 negative 11. So that has to equal x squared over 0.77. Right? Or no, 8.67? No, 8.7. Oh, this is x squared over, you have 0.77 here.
Oh yeah, I'm thinking right.
So you'll take this times 0.77 and then take square root and you'll have it. Okay.